All right, hey, organic chemistry. So we're gonna go and do some video notes with this packet that says Isomerism and configurations notes packet, and we're gonna jump to page 4, and we're gonna go through pages 4 through 7. So I wanted to start with reminding you and talking to you about cycloalkenes. Those are what we're gonna call rings. Okay, and don't forget that rings are a continuous circle of carbon circle or a chain of carbons that are connected on both ends. So it's as opposed to, like, let's say cyclopropane versus propane. Propane would look like this: one, two, three. Cyclopropane, one, two, three. It still has three carbons. They both have three carbons, but propane has 3, 4, 5, 6, 7, 8 hydrogens. Cyclopropane has 6 hydrogens. Rings follow the CnH2n rule. So if I had a ring that had 8 carbons, it would have 16 hydrogens. And that's cyclooctane down here. Each of these carbons, there's 8 of them, would have 2 hydrogens. 8 times 2 is 16. Now, I could name this as a parent name. If somehow I had a larger parent name and it became a substituent, I could name a ring as a substituent. So for example, if I had maybe a cyclobutyl, like if I had something like this, if I had cyclohexyl, or if I had cyclohexane and then cyclobutyl, this could be 1 cyclobutyl cyclohexane. Now that's ugly, I know. But sometimes I could have rings as substituents, and look at what happens to the ending of the name. They get -ul. Cyclohexyl, cycloheptyl, cyclooctyl, cyclobutyl, as opposed to cyclobutane, cyclohexane, cycloheptane. And don't forget that ANE is an alkene, which means all single bonds. Okay? Now, again, this, even though it's an alkene, it's a ring, so the ring follows the CnH2n rule. Okay? All right, now going a little bit more into, or back to isomers with rings, we can have what's known as cis-trans isomerism with rings. If I have a ring, I could call this ring Me, stands for methyl, which we know is CH3, right? So sometimes you can see Me as methyl, right? On my first and second carbon here, 1 and 2, and this will be 3, I can have methyl groups, but I could have these methyl groups in 2 different positions, and we're going to talk about that, and we're going to call them cis or trans. Flat, if I'm looking at it flat over here, this is going to be a flat 1,2 dimethyl cyclopropane. But this cyclopropane, 3-dimensional, is a little bit different than this 3-dimensional cyclopropane. These are both 1,2 dimethyl cyclopropane. Look at these two. These are the same, but how can I tell the difference if they're both called 1,2 dimethyl cyclopropane, right? If I'm just looking at it like this, 1, 2, this is methyl groups on both carbons, so 1 and 2 dimethyl cyclopropane, that's easy. But what if I have 3-dimensional, or which way or which direction will I have those methyl groups? Can I have them up or down? Can I have them on the same side, or can I have them on the opposite side? I'm going to call this same side of ring, or opposite sides of the ring. Do you see how there's a methyl group up and down here that's on opposite sides of the ring? And then I have 2 methyl groups that are up on the same sides? Just as a note, these 2 are actually totally different compounds. They are not constitutional isomers, even though they have the same molecular formula. Later, we're going to call these stereoisomers. All right, so these two compounds, the one that have the methyl groups on the same side and the opposite side, they're going to have different properties. That's why they're going to be totally different compounds. Now, they're going to have special names. The one that has the methyl groups on the same side of the ring, we're going to call this cis 1,2-dimethyl cyclopropane. Oops, that's all squished there. I'm sorry. And on opposite sides, we're going to call this trans 1,2-dimethyl cyclopropane. And so as you can see, the one that's on opposite sides of the ring, we call that trans. So we have two new vocabulary words that you're going to have to know. Cis has substituents on the same side of the ring. Substituents on the same side. And I'm going to call that, for this case, on the ring. And then trans is going to be substituents on opposite side. Substituents on opposite sides of the ring. This also works for alkenes, right? So again, these are going to be totally different compounds. These are not structural isomers or not constitutional isomers. We're going to call them stereoisomers. That's going to be later. Okay? So, we're going to do more practice and work with this. I'm going to end this video with just cis or trans isomerism. Move on to the next video, and in the next video, I'm going to be talking about ring conformations, right? More about this cis-trans and where I could put substituents in a six-membered ring.